Hello, this is Mr. Stansbury. I'm going to take you through the notes on sum and measures of interior angles of a polygon. At the end of this, you should be able to say that I can develop a formula for the sum of the measures of the interior angles of a polygon, and I can determine the sum of the measures of the interior angles of a polygon. Okay, so here's what we're going to do. We've got these different figures here that have 3, 4, 5, 6, 7, and 8 sides. And then we're also going to come up with a general formula, which is the n. Okay, what we're going to do with each of these is first figure out how many triangles there are in each one of these figures here. Okay, so here's what we're going to do with this. Basically, we know for sure that a triangle has a sum of 180 degrees. Right? So we know that this, if it's got 3 sides, it's a triangle, and the number of triangles, there is 1 triangle in there. And the number of degrees in a triangle we know is 180. So what we're going to do is take the number of triangles, 1, multiply it by the 180, and that will give us the sum of angles in the polygon, which in this case is 180 degrees. Okay? Hopefully this will make more sense with the next one. 4 sides. Nice little regular polygon would be a square. It doesn't have to be a square. It can be anything with 4 sides. But what we can do is we could split that into 2 different triangles, right? So this triangle here, we know it has 180. This triangle here has 180, so we take 2. We have 2 triangles that we fit in there. Both have 180 total degrees. 2 times 180 is 360. Okay, so same idea with 5. We can break, let's see, there's 1 triangle there, and then here's 2, and then 3 triangles total. So we have 3 triangles times 180. Let's make that look nicer. 180 is going to be 540 degrees. Okay, now hopefully you're starting to kind of figure out a pattern that's going on here. Here's 1. Oops, 1. There's another, and there are 2 more. So there are 4 total triangles here times 180 equals 720 degrees. 7 triangles. We can make 1, 2, 3, 4, and 5, right? So that's 5 triangles times 180. And let's see, that's going to be another 180. That's 900 degrees. And then for the last one that we're going to do on here is going to be the octagon. So 1, 2, 3, 4, 5, 6. Okay, so there are 6 total triangles. All have 180 degrees in them. And that is going to be 1080 degrees. Okay, now here's the good part down here. What we're going to do is we're going to come up with a general formula for all of these, so we don't have to go through and calculate each, go through and figure out how many triangles there are, multiply by 180 to get the total degrees. We're going to do this instead. So if you'll notice, n, let's say if it's got n number of sides, so what we want to do is kind of look at what's been happening up here and kind of try to find the pattern, right? So if we notice, we had 3 sides, it had 1 triangle. 4 sides had 2. So if you'll notice, we take the number of sides and you subtract 2. That's going to give us 1. Subtract 2 is going to give us 2. 5 minus 2 gives us 3, so forth and so on. So this right here, the number of triangles is going to be n minus 2. Okay, so however many sides there are, take away 2, and that will tell us how many triangles there are. Degrees in a triangle are always 180. So the sum of the angles in a polygon are going to be, remember, we always took the number of triangles times the degrees in a triangle, and we multiplied these 2 things together. So it's going to be n minus 2 times 180 degrees, and that is our formula that we can use for all of this. All right, so take the number of sides, subtract 2, and then multiply it by 180, and that will work for any number of sides you can come up with. So if we have a 20-sided polygon, 20 minus 2 is 18. Whatever 18 times 180 is will be the total number of angles in the polygon. All right? Okay, so let's take that information here and use it on that. So if you'll remember, our formula was n minus 2 times 180. So how many total interior degrees does a decagon have? So deca is, the way I always remember this is decathlon is an Olympic event, and that's when they have 10 events that they have to do. So that's going to be 10 minus 2 times 180. Right, so it's going to be 8 times 180. Okay, and do that on our calculator, and we get 1,440 degrees. Okay, 18-sided polygon, 18 minus 2 times 180 is going to be 16 times 180. And we do that in here. 16 times 180 gives us, that's going to have 2,880 total degrees on the inside. Okay? And just to kind of help you understand what the heck we're talking about, this 2,880, back to this here, all these, if you take this octagon, all these angles, these interior angles right here, if you add them all up, it's going to equal 1,080 total degrees. Okay? Okay. Last example here, but before we do that, let's take a quick little comedy break. All right. Last example here. Example, if a convex octagon has interior angle measures of 140, 143, 128, 116, 150, 143, and 137, which is 7 of the 8 angles, what is the measure of the 8th angle? So what we would do is, if we didn't have our little table that we have on that, our first page of notes here, we would simply just plug it into our formula, right? N minus 2 times 180. We know the number of sides is 8 minus 2 times 180 is going to give us 6 times 180. And we had that on there already before, which we knew was 1,080 total degrees. So we know that these 7 angles plus the last angle have to equal 1080. So let's do this. 1080 has to equal 140 plus 143 plus 128 plus 116, 150, 143, and let's see, 137, and our mystery last angle of x. Okay, so really what we're going to do is we're just going to add all these up and subtract whatever that number is from both sides, and it'll tell us what x is. Okay, so added all those up and we get 957. So we have 1080 equals 957 plus x. So we'll just want to subtract 957 from both sides, and that'll tell us what x is. So we got 1080 minus our answer of 957 leaves us with 123 degrees has to be what the 8th angle is. Okay? All right, that's all we have for some of the measures of the interior angles of a polygon. If you have any further questions, please feel free to ask. Thanks.